Hey guys, David here and welcome to another video. If you know guitar pickups, you might have heard of Fishman Fluence. They are really revolutionary in that they use PCBs instead of copper wire to create the coils for their pickups. A while ago I saw a video by Dylan Talks Tone who cut one of them open, and seeing the cross section immediately got my wheels turning, and I was like, would it be possible to build one of those myself? Well, here we are. Today I'm going to answer that question. And all of this would not have been possible without a great partner for this video, PCB Way, as well, a PCB pickup needs PCBs, and it turns out it's actually kind of difficult to manufacture those. So I will get more into that later, but first a big thanks to PCB Way for sponsoring this video and providing all the PCBs you will see here. They have super affordable PCB services for more basic prototyping boards, up to 2 layers, silk screen, everything very beautiful. Now, if you want to get into more fancy 4-layer boards and thinner stuff, then you might have to pay a little bit extra, but even then the prices are still extremely affordable. And if you're not looking for PCBs, but for maybe 3D printing or CNC machining, they also have manufacturing services that are as well extremely affordable, and you can get an instant online quote now. So make sure to go check out PCB, linked down below. Now, to give a little bit more context, as maybe not all of you are as familiar with guitar pickups, the way they work is that you have usually a bunch of copper wire wound up in a coil with some magnets or magnets underneath with metal pieces that bring the magnetic field up, and then the strings, the metal strings, vibrate over top, which changes the magnetic field, as the coil then senses that and creates an electric signal which can then be amplified by an amplifier. That's how pickups have worked forever, basically, since they were invented. And there are some companies that have made active versions where they add like a little bit of a preamp into the pickup, but still they use basically the same methodology of having copper wire wound around some pole pieces. Now, as I mentioned, Fishman, they have decided to forgo that copper winding process, which is not always super repeatable, as there's extremely many variables, like the thickness of the insulation on the copper wire, the exact thickness of the wire, and all of that has an influence in the tone. So instead, they have dialed down their manufacturing process for PCBs and can turn out many of them basically exactly the same. Now, sadly, Fishman pickups, they're kind of just epoxied in, and you can't really see much of PCB goodness at all. So until a while ago, there has been not really any information. I mean, there's the patent filings for the technology, but it of course doesn't go into the very details of how they actually do it. So I was very excited when I found a video by Dylan Talks Tone, and he used one of the single coils and actually used the Dremel to cut it open. Now, as sad as it is, it was a very great service to the community, being able to see inside. And from that, I was able to see that the coils they're using are 25 windings in like the horizontal directions, and then 25 of those stacked on top of each other. So it's a 25, at least a layer PCB, and quite narrow spacing, because to fit 25 layers, 25 tracks so close to each other, you need to have extremely tight spacing. Probably around 3 mil spacing at most, which, if you know PCBs, that's getting into advanced technology. And then they don't just have one of those coils, but a second one underneath that is slightly offset, and that allows them to use their DSP magic. As the other new thing about the Fishmans is that they use quite a bit of digital technology in there, and take the signals and have some fancy sound processing, which allows them to get the very unique voicings, and also gives you usually multiple different voicings for each pickup. Now, I will not have any chance of replicating the second stage of their process, as while I have taken some signals courses at uni, I was not a great fan of them, and I'm definitely not on any level that I could do anything like that. But the PCBs, that sounds doable. Now, I did have to cut down my constraints slightly. While PCB Way liked me, they don't like me as much that they want to sponsor a multi-$1,000 prototype PCB. If you make a lot of them, so like a couple thousand like Fishman is making, you can very much dial down your process and have a single monolithic 25 or a 30 layer PCB with very tight spacing. But if you just want one then they still have to make an entire sheet of that 25-layer PCB, although I just need this big of a PCB. So that was not an option. Instead, I kind of clicked through their online configurator and found that you can get a 0.6 millimeter thick PCB, which is very thin. It's about half the thickness of most PCBs. And you can get those with up to 4 layers at a very reasonable price. Now, of course, it's going to be more expensive than a regular 2-layer PCB, but 4 layers in 0.6 millimeters, that is quite impressive. And feeling them in my hand, it's even more impressive than on paper. Now, the minimum spacing that you can get for not really any additional charge is 5 mil, which is very quite small. I've used it before on very small occasions, just a couple tracks. But if you have a PCB, which is literally just a coil of 5 mil spacings, which I initially designed, their engineer is going to get back to you and be like, yes, you know, I gave you a quote for that, but like the online system gave you a quote, but this is actually really difficult to manufacture. So we'll have to do it in our advanced facility, which is going to cost like a lot more. So we're talking about like 4 to 5 times as much as the initial quote. So I went ahead and redesigned it, and they told me that for a coil in their regular factory, the minimum spacing is 10 mil, so 0.25 millimeters. Now that's a bit of a bummer, because that means that I cannot fit 25 tracks side by side, but in the very maximum space, which is actually wider than what Fishman is using, I'm able to fit 13. Which, I mean, is not ideal, but I can slightly make up for that by having more layers. I'm having 4 layers for each 0.6 millimeter PCB, and then I took 20 of those PCBs and put them on top of each other and connected all of them, which means that I have 80 layers of 13 wide, which is not quite as many winds as the Fishman's, but getting relatively close. Now that is just one coil, or 2 since it's a humbucker, and not 2 stacked on top of each other, but then the pickup will get way too thick. Even now, like the bottom ones are probably not contributing nearly as much to it anymore as the top ones, as they are starting to get quite a bit further away from the strings. Now, to actually design these coils, I used Altium Designer, but designing coils in there is kind of a pain since it keeps wanting to simplify it. So what I did is I designed the coils in Fusion 360 just in the Sketch workspace, since I know that the best. You could also use any other vector imaging software like Inkscape or Illustrator, and then exported it as a DXF, which you can import into Altium Designer, and then just set the lines as your tracks, and it works golden. And then I just added the vias and a couple paths, set the outline, and I was able to get the PCB basically exactly like I wanted without knowing Altium all that too well. I also went ahead and designed a little faceplate that sits on top that just connects the coils, like one for the humbucker, one coil is going this way, then it's going up, and then the next one is going that way down again. And it's just a little connection I designed since I thought it would look a lot better, and I had that ordered in special matte, and while their matte looks really nice, I actually found that the coils look really beautiful, and if I'd done it again, I would just design one with coils on top as well, and just not with the pads, as I like the look of the coils on top almost better. But that does not really matter for the performance, and I have some video here for you in both configurations. For the rest of the pickup, I'm using fairly standard parts, just like a nickel silver base plate that was already cut to shape for a 6-string humbucker. For the magnets, I'm using a ceramic magnet as I need the most power possible. I also got a ceramic, I also got an Alnico 7, I believe, but as you will be able to hear, it doesn't really make a difference which magnet I use in the end. Pull pieces are just standard pull pieces, and screws, all fairly off-the-shelf DIY pickup parts. Now, to connect all of the PCBs together, the most easy way would be just to have vias and stick a wire down and solder it, but that kind of eliminates the possibility of going in at the bottom layer, then going up 4 layers, and then coming at the same place and being able to stack the same PCB on top of each other. Like, I wanted to make sure that I can design just one 4-layer PCB and stack as many of them on top of each other as I want. So instead, what I used is I put a just SMD pad on both sides, and then the idea was to just put some solder paste on there, put them together, and then heat it from the outside and hope that it solders. Now it was slightly more tricky than I expected, but just going one layer at a time, heating from above, I was able to get it all soldered up and working. Well, the pickups looked fairly easy to manufacture and simple on the computer, where this small pickup here is blown up to this size. Actually holding them in my hands, I can definitely understand why they were not able to make them smaller, and I'm very impressed at being able to fit 4 layers into such a thin package. Like, these are roughly the thickness of a business card, like much thinner than a credit card. And having 4 layers in that is impressive. Now, sadly, I did have one of the coils that was not functioning. There was not continuity on one of the sides, which is not all that surprising. It's a very difficult thing to manufacture, and having just one tiny mistake anywhere on that PCB means that it's not working, because my coil literally goes everywhere. So, and if there is one discontinuity, then the entire thing doesn't work. And I didn't go for the testing service. If that is a problem for you and you're not just kind of measuring them anyhow, then you can have PCBWay test all the PCBs before they send them to you and make sure there's not any faulty ones. And that's not much of an extra charge either. But having it all soldered up, it worked nicely, and I actually got a decent resistance. Now, a regular humbucker is going to be a couple of kilo ohms. I'm a couple hundred ohms, so I am quite a bit slower. I think measured around 700 or 800 ohms, which is not as much as you would like. And I've already calculated, like, my number of windings are also a lot fewer than you would like. So I have about 5 to 10 times fewer windings and less resistance, which means that my inductance is also going to be about 5 times lower than with a regular humbucker. That doesn't matter, it might still work. So I put it in my guitar, which, if you haven't seen how I built this guitar, go check out the video linked down below and up in the cards. And I put it in there and plugged it in, not expecting it to work right away, but it worked. I didn't even notice that I was tuning the guitar with the pickups, because I'm so used to tuning with my amps and plugging that I realized, oh wait, the tuning is working, so that means the pickup must be working as well. If you know anything about sound, this is not the greatest pickup. Now, one of the main issues is that the output is very low. It's like almost at the point where if I strum very lightly, it doesn't even go past my noise gate for the regular pickups. And even if I strum quite hard, it's quite low input. That is not a huge surprise. And since I'm using software, I can easily just boost the signal, which then gives me higher input, but also more noise and stuff. But if you don't go for a clean tone, but something with a bit of gain and put some compression on there, then the low input is not that big of a deal anymore. But what you can also hear is that this thing sounds a bit like a tin can. There's a lot of highs, and playing solo stuff on the high strings actually sounds pretty decent. But if you try to hit any of the low strings, there's just no low mid-end and definitely no bass whatsoever there. Now, as far as my understanding of pickups go, to get more bass response, you need more windings, and I don't have a lot of windings, so I guess that makes sense. I'm not an expert in this field, just kind of read some things, but yeah, this does not sound great. But There's one last chance. Fishman is not using the direct signal from the PCB, so I have no idea how their direct from coil signal sounds. I'd expect it to sound slightly better than what I have here, but I also don't know. They're doing some sort of DSP magic. Now, I don't have that DSP magic, but what I can do is have a simple preamp. So I basically copied the EMG circuit, which is widely available on the internet. It's based on the LM4220 operational amplifier, and you can get those very cheaply online. So I put together a reactive circuit, which, by the way, if you think that EMGs are expensive because the active components are expensive, even just buying quantities of 10, the entire component cost for the active circuit is $150. So think about that next time you're shopping for pickups. Now, I had PCBWay also send me these active circuits right away in the beginning, since I already knew, based on the math, that the output was going to be very low and I'm going to need some preamp. And, well, I should have paid a bit more attention in my analog courses at uni, since, well, this is basically exactly what we learned there, but still actually applying it out in the field, where you don't have the perfect plots on the computer, it's a bit more difficult. I played around with it a bit, trying to change out the values, and I got a little bit more gain. I got a slightly higher output signal. Based on the sound here, well, it can amplify it, it can't create something that is not there. And the bass is just not there, so it's just going to amplify the highs more. Now, maybe if you integrated already a bit of an equalizer into that and put like a low-pass filter on there and boosted the lows a bit more, which is all things that you can do with analog circuits, you might be able to get slightly better performance. But I didn't do that, but I did try to just kind of put a bit of an EQ curve on it in software. And it does sound better. It doesn't sound like it's ripping your ears apart anymore. But it doesn't sound great either. The lows are not really there, but the little bit that is there, you can kind of boost and it sounds a bit more balanced. But there's this kind of popping sound almost on the high end. I'm not quite sure what that is coming from, but like basically it took up the entire low end up like 3 dB and took down the entire high end about 3 dB, which is a very aggressive EQ for just like within a guitar amplifier. I guess I am not really competition to Fishman with this. Not that I would ever sell this, since this is all patented, so this is all just for entertainment purposes anyhow. But for my newest guitar build, which you can already see a sneak peek behind me, I did buy some Fishman Fluence toes in the basins, and I bought those before I even finished this project, knowing that my version might not quite match up to their standards. So Fishman, if you're listening, really cool technology. I guess it does make sense why you charge so much for it. I have a much better understanding for that now, and I really do like the real deal. Now, this guitar is not quite 100% done yet, and I still have some issues, but I will put a little sample here for you to be able to compare. Not that it really matters that it's a completely different guitar and a different tuning, so it's not an apples-to-apples comparison, but I don't think you need an apples-to-apples comparison to hear the difference either. And with that, I hope you guys enjoyed this exploration video. If you did, please leave a like down below and leave a comment. Share this video to anyone that you think might be interested in this fun experiment. I have not really found anyone attempting this online, which is why I just had to try it. But I can also see why it's not really worth doing, especially since ordering just a couple pieces, this doesn't come out all that much cheaper. But it was definitely fun nonetheless, and learned a bunch. And with that, thank you guys for watching. Make sure to like, comment, subscribe, all that good stuff, and I'll see you next time with the build of this guitar.